Hello and welcome to Automation Talk. And if you haven't been with us before, my name is Shane Kreider, and joining me today is Richard Palmer. He's with our business development team. He comes in and helps me out. And thanks for coming over again, Richard.
Oh, thanks for having me, Shane.
As you know, you signed up for it, but today is our motor controls. Now, this is a little bit different because in the past we've done some our AC drives. We've done a very detailed web seminar on that, and it was actually Bill Boatwright out of our tech support team. He came over and did it. So if you want something a little bit more detailed on, say, drives, I suggest go back and watching that one. Now, Tom Malowski and I have done some on just some simple motor controls and stuff, but we've added some new products since then. So what Richard and I are going to do is just show you the things that we offer that you can use to control motors and why you would choose one over the other. Some of these products I didn't know about, but I've never been big on motors when I was out in the field. I tried to stay away from drives and stuff. It scared me. But anyway, everybody has their own little niche. But anyway, we're going to go through this. So first of all, we're going to start out with the agenda. Like I said, we're going to start out with motor controllers. Then we've got relays. What's the difference between the two, stuff like that. Soft starters. And then we'll get into the AC motor drives. Well, before we start into all of that, the reason why you're watching this is because you actually have a motor, as you can see on the slide, so you need to control that motor. Well, don't forget, Automation Direct carries motors. We carry all kinds of motors. We have AC motors, we have DC motors. As you can see on the slide, we have even the new NEMA high efficiency ones that the government has mandated. We're carrying those. We've had those actually for quite a while, but until all the suppliers run out of their old stock, we'll have the original ones until we run out of stock, and then that's all we'll be carrying. But Richard, you got anything you want to add on the motors, or?
No, that's not a lot more to say. I mean, motor's a motor. We've got a variety of different RPM ranges, and inverter duty motors as well as general purpose motors. So check those out.
Yeah, it just depends on what your application is. If you're just running a conveyor, you might just want to get a general purpose. If you're going to run some type of machine and you need to ramp up and down, stuff like that, you're worried about heat, yeah, you might want to look at a different type. And then you have different styles for what you're bolting up to them.
Mm-hmm. Yeah, right. I mean, there's all sorts of different face options. There's different mounting configurations, that sort of thing. And one of the things about general purpose versus the inverter duties is you hit on it right there in your little what you just said is heat.
Right.
Inverter duty motors are made to take the heat. They're made to be run at a turn down rate that's much more significant than the general purpose motor. So while you can't put a general purpose motor on a variable frequency drive, you really have to watch that heat, and you have to watch the turn down speed, because typically you don't want to run it less than 50% of the RPM range of the motor with a general purpose motor on the drive. So.
Yeah, there's a lot of things to take into account with that, but like I said, we've actually got some webcasts that we've done with just motors themselves, so feel free to go back and watch those as well. And always, if you have any questions, you can always contact Automation Direct. Our tech support's free, so go through that with them, and they'll help you walk through and pick out what's going to be right for you. Right. We don't have any up here, but we carry anything from a small one to one that would literally crack the concrete if we tried to bring it in here with a forklift. We actually, our warehouse, they had to pour special concrete on the floor just so they could carry this big huge motor so they didn't crack or bust the floor up. All right, next slide. Manual motor controllers. Well, actually only have one of these, and you can see it on the slide. And this is about as simple as it gets. It's almost like a light switch, right?
It's essentially a light switch as far as it goes. I mean, you can take one of these and you can mount it out there right at your motor for a local disconnecting means per, what the codes say you have to do. You have to have a motor disconnect within visible sight range of the motor. So you can mount this right there at the motor as a means to turn the motor right off. It's got a lockout built into it right there.
Yep.
So you've got your lockout tag out built right into the device. So really handy for taking and making a means to turn motors off right there at the motor.
Now these are actually new products that we just started carrying, maybe a month or so ago?
Yeah,
fairly recently.
Yeah, month or two.
Okay.
Month or two ago, yeah.
And so this gets as simple as it is. Like I said, you read on there, Bryant motor controllers is as simple as a toggle switch to activate a motor, and they can be used as the motor disconnects. And you can see the little graphic on there that it shows where you can use it as a disconnect. But
right.
Yeah, if you just want to be able to turn a conveyor on and turn it off for whatever your small machine is, then
right. We've got a few people that buy them for personal use things where they've got a shop and they've got some large machinery in a shop and they want to be able to turn it off and be sure that kids don't get into it. They'll get one of these and hang it up on the wall and
Not a bad
lock it
idea.
out.
I'm gonna lock out my whole shop. All right, let's move on to the next. Here's a little bit better explanation. Like Richard said, you can actually use these as the motor disconnect now, and that graphic shows it. Traditionally you had a controller and a disconnect, and now you actually can use them right at the motor as a disconnect. And there's a little bit more explanation down there. I forget where they got that info from. It's like NEC 2005, but yeah, so you can use these, but look up your local codes and whatnot. All right, starters and overloads. Now we carry a couple of different brands of starters and their overloads, and Fuji, which is a big name brand, and also Eaton, which Eaton Cutler Hammer, is a huge conglomerate of all kinds of stuff. But we carry both brands there, and I don't know. Richard.
We've also got the less expensive brand, which is GH series.
Right, which is our private labeled
That's
brand.
our private label brand.
Yes, and we have those in here as well. Now I've only got a couple of them up here on the table, but I don't know. It's hard to say. A motor controller is a motor controller.
Right. I mean, what you got in your hand, there's a contactor.
Right.
Contactor is it's basically just a relay.
Yeah.
There's not much difference to it. You've got a coil on it, or you attach two leads to it. You energize those. It causes the contactor to pull in and make power flow from the top to the bottom.
Right.
And it's got a little visual indicator right there on the front that shows you that it's engaged or not engaged.
Right.
There's also places on the side where you can take and put on auxiliary contacts to take and send a status back to, say, a PLC or something like that to know that the contactor has engaged.
And those just simply snap right on there. I was trying to remember on here. Yeah, it's basically the same thing as the contactor on the bottom. And trying to remember the accessories. I didn't bring any of the accessories out here. I apologize.
Yeah, we've got some interconnectors for like what you got in your hands, a manual motor starter.
Right.
And so basically this takes the part of protecting your motor right here on the top. It's a thermal disconnect type of thing. And then you've got a little interconnect block here, the contactor on the bottom, and turn it around the side. You can see it's got a nice base right here.
But you don't
for
have
mounting
to
it.
use all that, but it makes life easier.
It makes it a lot easier because this right here you can mount it on a piece of DIN rail.
Mhm.
Boom, click, you're done with it. Or you can take and tap a couple screws into it, either one.
Right.
Mounting it by itself, while you could do it, the extra couple bucks you'll spend for the base is
You're
well
gonna
worth
save
it.
labor,
You'll save
yes.
in labor.
So yeah, especially with if you want to try to run your own motor leads and whatnot, definitely. And this is actually a Fuji brand here, just in case anybody's curious about it. Anything on the slide? We'll make sure we're not missing anything. There's a selection chart. What's the difference between a contactor and a starter? And Richard's going to pop that up real quick, but there's a link on the slides. Usually we'll post the slides out on our website or whatnot, but you can find that by just going to Automation Direct and then going to the motor controls and going down. But Richard, let me get the guys, see if they can switch over to our PC feed. That way they can actually see the website there.
Right there.
See, this is on the Fuji one, but you can just, basically you scroll down and ask a couple of questions, and it's going to answer for you. What am I using it for? What do I need? And it'll help select for you. And once again, if that doesn't help you out and you still have some questions or some confusion on it, please feel free to contact our tech support. You can email them, you can fax them, you can get on the forum, you can call them, and they'll be glad to walk you through. I mean, that's what these guys are for. All right. This goes down a little bit more in depth on the Fuji motor contactors, the different series. Like I said, we've got from a 0.5 horsepower to 100 horsepower. All the other series, 60 to 300 horsepower, which is, some of these larger ones. Let me go back to, yeah, some of the larger ones we've got here. And those are quite heavy.
You get quite a variety of coil ranges in those for, if you need 24 volts DC or 24 volts AC, 110 volts AC, 220, etc. There's a wide variety of coils for the Fuji contactors.
Right. I've actually, and this is the one we just talked about a minute ago. I'll just leave that up while I'm talking. I've got a friend that's also a customer of ours, and every time I see him over here picking stuff up in the office, I'm like, hey, what are you getting? Because he was never really a PLC guy, but he's like, man, he says, I cannot find contactors and starters any better, any cheaper than you guys.
Yeah.
That's the only thing he buys from us, but that's the only thing he uses,
Right.
And being that he's a company owner, he's going to try to find the best product he can for the best price.
Absolutely. I mean, with the way the economy is these days, smart shopping's a must.
Yeah, definitely. We were all doing it. These are our Eaton Cutler hammer ones. I don't really have any of the Eaton Cutler hammer ones up here. Wasn't a whole lot to show other than the Fuji, but as you can see on the slides, like I said, we've got low horsepower solutions there, and we've got all the specs and the stats on that. But you can find all the same stuff on our website.
Right.
And like Richard said, if you're looking for even more cost competitive, the GH series, this is Automation Direct's private label. Doesn't mean it's worth any less. Doesn't mean it doesn't work as well. Our warranties, a lot of time with Automation Direct stuff, the warranties are usually a lot better than some of the name brand stuff. Personally, just working with a lot of our products that are private labeled or that we make ourselves are sometimes a lot better than the name brand stuff.
Oh, absolutely. I mean, you can get a great value by not buying a brand name and still get the same quality.
Sure.
Because it's just the way the brand labeling works. So you can definitely make some really good buys and have the same exact quality you're paying for the name brand.
Right.
By buying a brand that we have private labeled.
Yes, definitely. And these are considered IEC on those the GH series. All right, we're going to move on to something we'll probably spend a little bit more time on. Is going to be soft starters. I didn't really know what soft starter was until we started carrying them. We started talking about them, and of course we have our training classes or whatnot. But yeah, I mean, you don't have to go from simple straight into an AC drive and have something that you got to connect up and program or all that. They might be a little intimidating. And soft starters are a great middle of the road if you don't need the fully programmable, but you don't need something to kick on.
Right. The thing about a soft starter is a lot of utility companies charge demand charges.
Right.
They charge demand charges every time you kick that 100-horse motor on or off because it creates a huge pull on their line.
Right.
They have to create extra electricity to take up that slack that you just put on their lines from starting that 100-horse motor across the line.
Now, what if you have a whole plant with, say, multiple machines with that same 100 horsepower motor?
The utility company is going to come to you and they're going to say, Mr. Business Owner, you need to do something about this plant starting up all at once because this is not acceptable.
Now, obviously, you wouldn't start. Let's just say the plant has 300 machines and they all have the same 100 horsepower motor. You're not going to turn them all on at the same time.
Hopefully not.
But, within a day, you might be ramping up production.
Yeah, you might ramp up production in a matter of a few hours. And, kicking on motors like that, I mean, your electricity bill's just racking up.
Oh, yes.
You go outside, you can't see the wheel spinning. So the soft starter's a way to get around that.
Right.
What it does is you have your motor connections in and out. You've got some control connections on it where you would hook to PLC or your starter push button or whatever it might happen to be.
Right.
And what this does is you set a ramp using these dials on the face of it, and that will take the motor from stop speed up to the full speed and then kick it over to an actual contactor that keeps the thing running. And so, it's a great way to take and lessen those demand charges.
Right.
You can typically save a lot of money by installing soft starts in place of a regular starter for motors. I typically suggest around the 20 to 25 horse range. Sometimes it's cheap. It's a lot lower than that if you have a lot of 10 horse motors or something like that. It's still maybe worth putting the soft starters in there.
I knew that one of the product manager of these particular products, he's actually in a training class today. So that's why I asked him. I was like trying to beg him to come in here and he could dig into it a little bit better. And he's like, man, he said, if you could just connect a motor up to each one of these and show what the load was when you turn them on, he says, you'll be so surprised. But unfortunately, I only have 120 volts in this particular video lab, so we couldn't bring in any of the motors and connect them up.
Yeah, but the soft starters are a great way to take and reduce demand charges from your electric company.
Right.
And if you own a company and you have access to the electric bill, you can see what your demand charges are because they split them out usually on your bill and tell you what your demand charges are.
Right.
And taking and put motors on soft starters is a great way to reduce that.
And it's really simple. I don't know if you can. It's hard to see. TJ, if you can, let me see if we can go back over there. If he's got a shot on that one, I know we've got the graphics up there, but get the video shot. These are really simple. They're really no programmable. Like Richard was saying, it's just a selection on there. It's basically a potentiometer. A selection type style. There you go. That's a good shot. There you go. It's just a couple little selections there, and it's really easy to program.
Right. Yeah. These are the real simple ones. You get up to some of the larger ones, and they get a little more complicated to program, but still, yet, again, it's a great way to take and reduce your bills,
Right.
your electric bills, because electric bills can make or break a manufacturing facility.
Yeah, especially in
So-
today's economy.
Right. So by taking and adding a soft start in place of motor contactor, if the motor contactor goes bad, instead of buying just another plain motor contactor, replace it with a soft start.
Mm-hmm.
You'll probably realize the money back fairly quickly.
Definitely. All right, the next soft start we have is called a fully programmable soft start, right?
Right.
And I don't know, I'm sort of speechless on them.
Well, it's the same type of concept as the smaller ones, but these big ones here, they take and are for bigger motors. They're for the 25 horse and on up motors. The ones that are really, really big, and those are the typical places you're going to see soft starters a lot at. You could use a variable frequency drive, or you could use a soft starter. But if the motor's always going to be running at 100%,
Yes.
and you never need to slow it down, the VFD's kind of overkill for it. Soft starter is usually going to take and be a little bit of a cost savings over the VFD.
And these are fully programmable through,
Right. So you can program the ramp delay, you can program the steepness of the slope, all that sort of stuff to get the motor up to speed in the best fashion.
Now, what about coming down off of speed? Now, is it any programmable coming down off speed, or are they just pretty much ship?
Typically not. Typically you have them cut speed same as a motor contactor, and it just drops off. If you need to coast back down, that's one of those cases you might want to be thinking about a VFD.
Okay.
Because coasting down a motor, especially if it's a motor with a high torque load or high inertia with it,
Mm-hmm.
Coming back down, it generates a lot of back electricity
Yes.
as it's slowing down, and you have to have some place to absorb that electricity. You can't just feed it back on the line.
Sure you can.
Electric company doesn't like that. But, so you'd use a VFD in that case, and you might put on a resistor pack or some heater coils or something like that to absorb that energy and dissipate it safely.
Right.
So that would be a case where where a VFD might be more of a the appropriate thing to use in that situation.
Okay. And these soft starters they're actually our private label brand. It's called Stellar is the label or the name brand that we put on them. But yeah, we came out with these. I know that we came out with the first off soft starter. Excuse me. I don't know. It's been a while.
It's been over a year.
Okay, that's what I want to say. Over a year now. The newer ones we came out with this year. The full featured
Right.
ones came out this year in 2011. All right, we'll go to the next slide. Soft starters, like applications, we didn't really get into a whole lot of, and we don't really do a whole lot of app stories anymore or app notes. It'd be nice if we had some good ones, but things like as you see listed there, air compressors, agitators, conveyors, crushers, certain things that a soft starter would work great on. Other
Conveying
things,
systems,
Right.
Wood chippers, tumblers, any kind of milling application, big rotary drums that are turning, that sort of thing.
Right.
Yeah, soft starters are really good for that type of thing.
And as you can see on the bottom, why would you use it? You use it to reduce the voltage and acceleration and deceleration. All right, next and last is going to be, if you're going from bare minimum, which is, just a switch to turn on and off, then you move up through contactors and then soft starters, and the last is going to be sort of like the Cadillac of everything. You have full control of your motor. It's going to be an AC drive. And we've got 3 different types of AC drives or brands of AC drives, and they're all Automation Direct AC drives, but we got GS1, GS2, and then the Durapulse. And they go, sorry, I thought that next slide would have all the ranges, but they go anything from a small one, as you can see on the table, right here, up to a larger one that's...
You go anywhere from a quarter horse up to 100 horse is what we sell.
Right. And
So-
I didn't bring a large one in because I don't want to carry around a,
The 100 horse drive weighs just a little bit of money.
If you go to
so it's one of those things of you can take and get one of those big ones. I used to mount 100 horse drives using a forklift because I got tired of lifting.
yes. So I don't have one in here. I apologize, but you get mad if you want to.
Yeah, there's no way to get a forklift in here.
No.
Well, I guess we could once.
Once. We if you go and look at our Durapulse website, the intro was Chip. He was bringing in one, and we actually brought it in on a forklift and slams it down. That's how large they are and how much they weigh. But yeah, AC drives. Like it says on the slide, there's many benefits in using an AC drive. You have full control, as you can see there. They're showing a graphic of it, Ethernet control. So you're using it on your network. You're talking to it with a PLC or some other device. We have Ethernet cards for the drives.
Right, and that's one thing. The new Ethernet interface to the drives has been redesigned. So if you've been using it before and you're used to the big wide, takes up a lot of DIN rail space, it's now in one of those nice, sleek little blue packages that takes up very, very minimal amount of DIN rail space. You're looking at approximately an inch of DIN rail space. So it's a huge, huge amount of savings for a panel.
We
in the space requirements
right
that it takes. So.
We want to we've actually used that particular one in some of our Learn videos. So you can go to either YouTube or you can go to our Learn site and look at. I want to say it was either communications or it might have been like some type of drives video that Tom and I had done. But we were using like a Click PLC, or going to the ECOM or the Ethernet communications module, going out to a drive and showing how it actually works. So take a look at that if you want to. There gives you a little bit more information on it and how they actually work. AC drives. Anything else? Benefits of using an AC drive? Like I said, you have pretty much control.
You've got a lot of control of basically everything about the motor. You can take and set Excel times that are incredibly long times to get the motor up to speed. Minutes even to get a motor up to speed. You can set trip points for amperage. You can overspeed the motor with a variable frequency drive. Of course, if you do that, you need to take and do the engineering behind it to make sure that your motor is going to be able to handle the torque at the speed that you're trying to get it to. And most motor manufacturers have curves and or recommendations as to a turn down ratio that you can get the drive below its frequency, as well as below its rated frequency, typically 60 hertz, as well as above its rated frequency.
Right.
So, if you want to overspeed or run a motor really slow with a variable frequency drive, you need to pay a lot of attention to those things and watch the heat, that type of thing.
On the drives that Automation Direct sells, I know one of the big benefits, and it's something was the few motors and drives that I did mess with in the field. I had one go out on a machine. It was a clamshell press, and it was something that you didn't want running wide open all the time. Well, the drive went out, and they took it upon themselves to throw in some contactors and wire it up in a star delta so it would spin up. I mean, this thing had a flywheel this tall. It took a forklift to get it off, but it was funny when it was running at full blast and you stopped the machine, it would just shake the whole building. And I'm like, guys, there's a reason there was a drive on there. But yeah, the drives that they tried to replace it with was one of our competitors, and the programming just to get it out of the box and get it up and going was just horrific.
Some competitor stuff is very difficult to program, and that's one of the things we really took and worked hard on when we did the GS series of drives. We spent months taking and paring the list of parameters down for the stuff that you actually needed to see into the first couple of menus versus having everything up front. So, matter of fact, if you want to go in there and you just want to do a plain pump application, you can go in. There's a place in the drive to say, I'm doing a pumping application or a fan application, or I'm doing another type of application, and it will set the drive up mostly for you. You still have to do some tweaking, but it gets you a lot closer to being there than taking and having to go punch in every parameter by hand.
And some parameters on other manufacturers' competitive stuff, you're just like, what do they mean by that? What?
Yeah, the techno speak.
The mop ref.
Couple things on doing drives. Here on this drawing right here, you can see you've got your disconnecting means up in the front, and you got some fuses. And the reason we recommend fuses for our drives, and we get this call in technical support on a very regular basis, is can I run my drive off of a circuit breaker?
Okay.
Very, very common question. The answer is sure, you can run it off your circuit breaker, but the problem is the circuit breaker is not fast enough to take and protect the drive.
Okay.
Drive electronics will be damaged by the time the circuit breaker trips. So you've made yourself a very expensive doorstop by not using fuses. So
Okay.
that's the really short version of why not to use a circuit breaker.
Right.
You're going to make a really nice doorstop. Fuses are recommended for a reason, and it's because the rise time of the fuse matches the internal circuitry of the drive, and the fuses are very, very carefully picked to match up with the drive.
Okay.
So one thing that you want to do, you can put a contactor in there to take and turn the voltage on and off to the drive if you need to,
Right.
for safety reasons, OSHA, to totally remove power.
Could you use one of these, or you gotta?
You could use something like this. I mean, you could use a disconnecting means, but some people want to use a contactor because whenever the guy hits the e-stop, it needs
wants
to
to drop
needs to
everything.
drop
I
everything right
understand.
then.
Okay.
Then you've got your RF filter. Some drive installations don't necessarily need an RF filter.
Mhm.
Others do. It's one of those things. My general rule of thumb is try it. If you start getting interference on some of your other electronics, put in the filter.
Right.
Then you've got your line reactor. Line reactor takes and keeps a lot of that interference from flowing upstream when it's put ahead of the drive.
Yes.
It takes and attenuates that interference that the drive's throwing out from the internal thyristor network to drop a lot of the noise from going back upstream into the utility power.
Okay.
And you got your drive itself. And then on the downstream side, you also have possibly a line reactor. And if you're running long runs to the drive of motor leads, you want to put in a line reactor. And why is that? Well, because basically on the output of the drive, you're putting out radio frequencies, and those radio frequencies get to the end of the line to the motor, and they actually bounce back.
Okay.
It's a much reduced waveform, but it does bounce back and reflect back towards the drive. And if it gets back to the drive, it's capable of taking and making the output pulses increase or decrease.
Right.
And that takes in once those pulses get to the drive, it starts heating the motor up.
Sure.
And you keep doing this, and that motor keeps getting a little bit hotter and a little bit harder and a little bit harder, and pretty soon you've got yourself a really nice smoke cloud going.
I'm sure.
That's the reason for putting the line reactor on the output of a drive for long distance cable runs.
Okay.
It's cheap insurance,
Right.
because you put a motor out there, even if you put an inverter duty motor, there's no guarantee that it's not going to get too hot with a long cable run.
Right.
So if you're running long cable runs, and somebody's going to ask, well, what's a long cable run? For me, it's anything over about 20, 25 feet.
Right.
Your mileage may vary, but I would, for any drive installation, I just put a line reactor in there myself. Whenever I was doing it back years ago before I came to ADC,
Right.
I just put line reactors in everything because it's cheap insurance for the motor.
Sure.
So-
Use all the insurance you can.
Right.
And if you have any questions on any of this stuff when you're starting to select, or if you're working on a current application, you're having issues, then you know what we're talking about. Feel free to call the
Absolutely.
tech support.
We've got some of the best drive guys in the business
We've
on
yeah,
the tech support line.
and that
they
is
know
their specialty.
That's their specialty. They don't do a whole lot of anything else. Some of them do answer other questions aside from that, but I mean, we've got guys that know a lot about drives and the motor controls in general.
Right.
So, that's a great resource. It's free. Take advantage of it.
Let me see if I can. There we go. Well, I think we sort of covered all this. I know it's a lot to throw in 20, 30 minutes, but the main focus was to show you what Automation Direct has that can control a motor. So now you can go as simple as a switch, or you can go as complicated as, I don't want to say complicated, but it is complicated,
advanced.
complex, yet advanced. Better word, advanced as a AC drive.
Right.
So and anytime you have any questions about this stuff, feel free to contact our tech department, and they'll be glad to walk you through it, help you with selection
Absolutely.
and whatnot.
Shoot them an email, call them on the phone. However you want to do it, they'll get you the answer.
Okay. All right, we're going to pause for just a quick second because we're pretty much run out of time. But if there's any questions anybody in the audience has, click on the ask a question button, ask away, and we'll answer it. If we don't answer it here, or if I get to it too late, don't worry, we'll email you a response. So, Richard, anything that you've seen in the past, people were typically asking about motor controls or best way to select anything?
Well, I mean, the whole selection of motor controls, you need to think about what the end result is. If you just need the motor to spool up and run at full blast, Like say for a consumer application might be a table saw. Let's just use that since everybody's kind of familiar with
Okay.
what a table saw does. You know, you don't really need to adjust the speed on a table saw.
No.
The motor runs, the blade turns, you push wood through it.
Right.
Whereas a drill press, on the other hand, sometimes you need to slow that thing down a little bit to take and not burn the bit up. If
Sure.
you're drilling aluminum or stainless, you don't want to run it full blast. So you might want to take and put a small drive on there, assuming it's a 3-phase motor on the drill
Right.
press. So that way would be a good selection for the for a VFD or a variable frequency drive. The selecting a soft start, again, you're running something really big, really heavy. Maybe an air compressor that's got a huge motor on it.
Sure.
That's got a 20 horsepower motor or something like that. You see the lights dim in your building every time it kicks on.
Right.
That might be a great application for a soft starter because it does need to run full blast, but you don't want it taking and just bang and going full blast immediately. You want it to take a few seconds to get up to speed. So that'd be a good application for a soft start.
Right. You're right. Okay. Well, we don't have any other questions. Some of them people had asked in the beginning when we first started out, but more of it was like motion control. This is more motor control. We've done some webcast on motion control, and we'll probably do some more later. But if you want that route, we've actually got some recorded ones you can go back and watch. And like I mentioned earlier, is if you're not familiar with the AC drives, we actually have a very detailed one. It's an older webcast, but it is very detailed. Bill Boatwright from our tech support, he was over here helping with that
Bill
one.
knows a lot about drives.
Yeah, he sure does. And he loves his job. He won't leave that desk. So, actually, we just got one popped up. What about the cable type for RF filters?
Yeah, if you're using VFD specific cable, it all depends on your setup. I mean, VFDs are very dependent upon grounding. If you don't ground them properly, you end up with lots of noise.
Yes.
And so ground it per what the manual says. And be sure to ground it to the specific point using the size of ground wire specified by NEC. And be sure that you're using point-to-point ground. Don't daisy chain. You'd be surprised at the number of places I go to and I see the ground wire coming out of one place, going up into another, over into another, and into another. And all you're doing there is just making more noise than what you're getting rid of with ground wire. So going back to what the original question was, VFD-specific cable, it's good stuff. In some instances, I don't necessarily think it's always needed. It's a personal preference of mine.
Right.
If I was putting it in to someplace and had to be near other equipment or other wiring, I might consider it. But I would still be putting in the filtering just because if you need VFD specific cabling, you're probably going to need the filtering.
Now, what Richard is talking about is you talk about noise and stuff like that. You might have somebody, say one engineer or technician comes in and installs a drive. Wires up a machine. They don't care what happens outside of that. As long as their equipment works, their drive works, their motor spins, the machine runs, it's good to go. Well, then here comes another guy that's going to be working with, say, a PLC that has communications back through, a computer or the network. Or they're using some type of remote I/O or something like that, and they're like, hey, I keep getting dropouts on my communications.
Absolutely.
What's going on?
Absolutely. And we get a lot of calls like that. My Seymour screen went blank. We get calls of, my PLC's, the CPU light randomly comes on.
Right.
And all those are symptoms of noise.
Sure.
And noise, as the way we're defining it here, is unwanted radio frequency communications that are on the power supply or on a communications cable. So VFDs are really big about making noise. You need to take steps to correct it. Part of that correction is using the correct filtering, line reactors, RF filters, and taking and using good cabling techniques and good grounding techniques.
Right. We've had a couple more fall in here. We're going to take one last one and then we'll move forward. Any special feature for the motors required when using a VFD?
No, not particularly. I mean, the thing about using VFDs and motors is if you're using a general purpose motor, don't go below 50% of its rated speed.
Right.
If you need to go less than 50%, get yourself an inverter duty motor. One that's made for use with VFDs. If you're going to overspeed the motor, get an inverter duty motor as well. Either one of those two cases The inverter duty motor is going to be able to handle the strain much better than a general purpose motor is. So, select your motor with a thought to the speed you're going to be running at the majority of the time. If you're taking and bringing something up to speed, and it's going to be at a speed for just a few seconds and then ramping up to full speed.
Right.
The general purpose motor may or may not handle that okay, but general rule of thumb, less than 50%, get yourself an inverter duty motor. Over speed, get yourself an inverter duty motor.
Okay. Cool. Good answer. All right. Any of those other questions that came through, don't worry. We'll answer them. Follow up on some emails. And like I said, if you have some more questions, feel free to go ahead and dump them in, and we'll still answer those later on, or we'll get you in contact with the right guys, which is typically, the guys over in tech support. But thank you for all those questions. Thank you for all the answers.
Thanks for having me, Shane.
All right, now we're at the end, so please don't log out yet. The guys are going to start up a little ending video that just shows you some stuff. We're going to give away some free stuff, so please watch it. And Richard, thanks once again for coming in.
Absolutely.
I really appreciate it. And we thank
fun.
our audience for coming in and logging in and watching us for 30 minutes. So thanks, everybody, and have a great day.